On this 2011 to 2022 F250 Superduty with the 6.2 gas engine, P0562, may point us toward a low system voltage condition. The truck may show weak cranking, warning lights, electrical resets, or other module behavior when voltage supply is unstable. Broadly, this can involve the battery and charging side, power feeds, grounds, wiring resistance, connectors, terminals, or a module reacting to poor voltage. Start by treating the concern as present only if you can actually confirm it. If the concern is not there while you are testing, do not condemn modules or other parts just because the code path seems to point that way. Before you start connecting meters, jumpers, or test equipment, protect the connector terminals. Use the proper flex probes or terminal probe kit so you are not spreading pins or damaging terminals. Check male to female terminal fit with the mating pin and pay attention to separation force. If the pin has very low separation force, treat that pin as damaged. If the connector shell, pin guide, or retainer is creating drag and masking the feel of a small terminal, remove the small pin from the shell so you can check it correctly. Any damaged connector, pin, or terminal needs to be corrected by replacing the damaged piece. Next, use the scan tool to look at PID input values, output states, and diagnostic states. The data logger is useful here because it lets you watch what the module is seeing without tearing the vehicle apart first. If output commands are available, use them only as part of the diagnostic logic to see how the system responds. Do not apply ground or power directly to module-switched components with jumper wires unless the test specifically directs it, because that direct connection can damage the component. When modules are involved, understand the normal function first. Make sure programmable parameters are set correctly, and stay with DTC-directed testing before even thinking about a module. Check the module inputs, both hardwired and networked. Check outputs with the proper switching circuit method, and consider available software updates. If other codes are present, check what they mean first, and do not let a voltage-related code turn into a blind module replacement. For a low-voltage type fault, do not trust a power feed voltage check with the intended load disconnected. That kind of check may only show you an open fuse or a completely open circuit. To find excessive resistance, the circuit has to be loaded. For circuits carrying approximately 200 to 1000 milliamps, load the circuit with a 250 to 350 milliamps test light and measure voltage with a DMM while that load is connected. If voltage drops during the loaded test, that points to excessive circuit resistance. Conductor size helps you choose a sensible load. Conductor sizes 24 gauge, 0.5 millimeters or smaller are generally used to carry approximately 1000 milliamps, 1 ampere, or less. For circuits carrying more than 1 ampere, use a load that requires similar current, such as a brake light bulb. Conductor sizes 20 gauge, 0.8 millimeters, or larger are generally used to carry 1 ampere, 1000 milliamps, or more. On higher current circuits, voltage drop testing is the better method. Check ground-providing circuits while the component is operating, or at least while you are attempting to operate it, by measuring voltage drop. Use an ohm meter on ground circuits only after the battery has been disconnected, because normal voltage in the vehicle can corrupt the reading. For most small diameter wires, 18 gauge and smaller, expect less than 2 ohms. For most wiring harness circuits, expect less than 2 ohms of resistance, and use voltage drop testing for higher current circuits. A standard DMM ohm meter's low resistance resolution is approximately 0.1 ohm, which limits accurate use to circuits carrying less than approximately 5 amperes. If you are measuring resistance, reverse the DMM leads and look for changes. The reading should not change unless a semiconductor is in the circuit. If it does change, the result is not valid. To check for unwanted continuity to ground, disconnect both ends of the suspect circuit and measure between that circuit and ground. The expected resistance is greater than 10,000 ohms. To check for unwanted continuity to another unpowered circuit, disconnect both ends of both circuits and measure between them. Again, the expected resistance is greater than 10,000 ohms. To check for unwanted continuity to a powered circuit, disconnect both ends of the suspect circuit, turn on ignition run power, and check for voltage between the suspect circuit and ground. The expected result is no voltage. Backprobing has its place, but only when the circuit must be tested under actual operating conditions or when voltage drop testing requires it. Do not force leads or probes into connectors, and use probes made for that job. Back probing is not the right method for a simple single-point voltage check when 0 volts is a possible result, and it is not the right way to check continuity or opens with an ohm meter between 2 points. Disconnect and isolate the circuit when that is the proper test. If you use jumper wires to create a substitute circuit, always use fused jumper wires and flex probes or equivalent, so you do not damage the harness or terminals. The recommended universal testing jumper wire fuse is 5 amperes or less. Flex probes are not intended to carry high current greater than 5 amperes, so do not use them to power high current loads. And do not repair a failed circuit by just adding a new wire in parallel. Find the fault, examine the damaged area, and repair the cause. For voltage drop testing, put the voltmeter at the beginning and end of the suspect circuit. Operate or attempt to operate the circuit, and follow conventional current flow for meter polarity. A 0-volt reading does not automatically prove the circuit is perfect. It can also mean the meter connections are bad or the component is not actually turned on. A normal voltage drop test will show a small amount of voltage, typically less than 5% of circuit operating voltage. In 12-volt circuits, that is usually less than 0.5 volts, again expecting less than 5% of circuit operating voltage. More than 0.5 volts indicates abnormal voltage loss from high resistance in wiring or connectors. For voltage in, voltage out testing, connect the negative meter lead to ground or battery negative. Operate or attempt to operate the circuit, and measure first on the power side of the load and then on the negative side. The power side should be within 0.5 volts of battery voltage. The ground side should be greater than 0 volts, but less than 0.5 volts. If you see 0 volts or source voltage in that testing, think open circuit and keep tracing the side that does not match the expected result. The takeaway on P0562 is simple. Prove the concern is active. Protect the terminals, use scan data intelligently, and test power and ground circuits under load. Low-voltage diagnostics are about finding voltage loss, not guessing at parts. For more diagnostic training, visit stepdiagnostics.com.